Hello students, I hope you all are good and enjoying at your homes. Uh, you have revised your previous lectures. Today we are going to discuss about branches, that is also called jumps, and some other topics like how can we use branches, jumps for delay or for loop purposes, and similarly we will also discuss about call instructions, and then we will move on to IO programmings and how we can use our these branches and these stuff tools for our programming purpose. Any idea about what is the purpose of branches or jumps? You people might be not much familiar with the assembly language, but you are familiar with the C language, Java language, or MATLAB programming. Any idea where we use branches or jumps? Okay, I hope you everyone have some idea. You know, we are mainly we have jumps which are unconditional jumps and conditional jumps. Any examples of conditional or unconditional jumps in C programming, let's say, or in Java programming, let's say? When you say in your C programming or in some other programming, you say go to some instruction, then it's mean you had a program, you have a multiple instructions. For example, 0 instruction, 1 2 3 4 5 6 7 8, you have 8 instructions, and at instruction 2 you want to go at instruction 8, and you want to go without any condition. What you will use, you can use go to. Similarly, if you have seen case instruction where you have case, and then once your case has met, what you do, you just put a break. And for example, here at this instruction your case was okay. What you are doing, you run that case, but after running that case you take a break. That break itself bring you out of that all case statement, all the remaining case statement which has not yet been checked by your program, and you come out of that case. How you do it? With unconditional jumps. So these are examples of unconditional jumps. Any examples of conditional jump? Yes, agree. For example, you are using if for example A is equal to B, then do this, else do this. If your this condition is not correct, what you are doing, you are going from this position. These all instructions should not be executed, all instructions should be skipped, and you come at else position. But if your else is correct, you execute these all instruction, but no, you will not execute the instruction which are in the else block. And here what are you doing, you are taking actually jump. If is correct, you are not, you will take jump from here to end of else. If this condition is not true, what you will do, you will take jump from here to this point, and you will run all the else conditions. Any other example of conditional jumps? For example, loops. What you do in your loop? For I is equal to 0, I less than or equal to 10, I plus plus. What you are doing? You run this program, and at the end you check that if your condition is still not meeting, your condition I is less than 10, what you do, you take jump and come again here. 1 2, 3, 4, 5, 6, 7, 8, 9, 10, until your eye is incrementing every time and it reaches to the value of 10. You are taking jumps from here to here. So you are checking the value of this. If this is true, you will execute this code, otherwise you will not execute this code and you will bypass this code. Similarly, while loop, do while loop, and there in all loops, when you have a condition, you check that condition and then you decide that you want to execute some particular portion of code, or you do not want to execute that particular portion of code. So branches or jumps are actually very much important, and we need this for our code. Why? Because sometime we want to skip the code, sometime we want to skip a particular code, or we want to go at particular code without any condition, and sometime we want to go with particular conditions. So particularly in loops, when we want to repeat a process multiple times, we need a conditional jump, so we can come back to our code where we want to repeat it multiple times. So these are very much important. But to execute these instructions, we should have some hardware behind it, which should be possible. So you have already learned about the architecture of a VR, or the basic blocks of some processor or microcontroller. So I am not going to that architecture part, but you know that there is some architecture block where we can check and this, but know how to program it in assembly. This is the main thing. If you have all your these instructions will be translated into machine instructions. Machine instruction is difficult to understand, so we have assembly instructions, and by using assembly instruction you have direct control on your processor. You know what it is doing at that time, what registers values are, and how you can manipulate those register values, and these all things. So how can we program this conditional or unconditional jumps in our assembly language? This is our lecture. In AVR programming, you have, for unconditional jumps, you have R jump instruction and you have jump instruction. What is R jump and what is jump instruction? With this, you will mention our address where you want to go. R jump is a relative jump. Relative jump is, for example, if you are standing at this portion, let's say this is your 5th floor, what you will do, you want to go at 10th or you want to go at 3rd floor. How will you say? You can say go up 5 floors up. You are standing at 5th floor, you want to go at 10th floor, you will simply say go plus 5 and you will reach at 10th floor. If you want to go at 3rd floor, you simply will say go minus 2. So where you are standing, you tell the address or location relatively, go this much up or go this much low. So if you are at this address at 4th instruction, if you want to go at 2nd instruction, you will simply say go 2 instructions back or go 2 instructions forward. So this is relatively. But if you are standing on at the same position, 5th floor, but you want to use absolute value, not relative value, what you will say? You will ask that go to 10th floor or go to 2nd floor. So actually you are not telling the relative address, that increment 5 times, you are simply say go at 10th floor, it will automatically find that 10 minus 5 is 5, and it will go this much ahead or forward or backward. Similarly, if you want to go at 3rd floor, you will here write 3, that go to 3, third address. Instead of here, you want to say go minus 2, go minus or plus 2, because we are moving forward direction. So this is the difference. Here in relative jump, we tell the address in terms of relative form, go up or go backward, go forward or backward this much, or how many instruction go forward or how many instruction go forward. Your assembler automatically find that okay, if you want to say, here we are actually in assembly language, how we write this address? We write this address by using the label. For example, this is our label L0, L1, L2, L3 and label 8. We have 8 instruction, and we have labeled these instructions with label 0, label 1 and label 8. So here what we will write, label 5. It here your assembler what will do, it will find okay, label 5 is one instruction ahead of it, so it will subtract it 5 minus 4 and it will write here plus 1. Our jump instruction code, this is a, for example, code, uh, a machine instruction. Here it will be our jump instruction. You have already gone through with this structure of instructions, and here it will simply write that L5, what is that? It was plus 1. So binary of plus 1, starting from that position to that position. So from this position to this position. How much relative jump we can take? Our AVR in our AVR at Mega 16, we can take jump from minus 2078 to 2077, minus 2k to, or you can say minus 2k to plus 2k. So if your label where you want to jump is inside this address 2k to plus 2k, then your R jump will work. If for example you want to move from L0 to L3000, what will happen? This R jump will not work. Why? Because no, your address is out of this boundary, that is 2k. Similarly, if you are at instruction 3000 and you want to go back to L0 and you say R jump label L0, it will not work. So what is the solution? Solution is jump. Here you can move to any part of your memory on the full size, but this instruction is 16-bit instruction and this instruction is 32-bit instruction. So but some code is used for jump to guide that this instruction is jump, the remaining is for the address where you can put the whole address, or you can give the absolute value. Jump to label 3000 mean it will find the address of this instruction, that is in this moment it is 3000, it will write binary of 3000 code for this instruction. So this is the difference between R jump and jump instruction. In book you can find some examples. Now come to branch instructions or some conditional instructions. What are conditional instructions? We have already discussed that in C or Java programming we are using if instruction, loops instruction, where we need to take jump, but we take that jump on some particular condition. So how to execute or how to program our AVR in assembly language? You know, you have some idea about flag register or status register, that when there is a status register which have 8 flags, 8 flags, this is your status register. Every processor have this status register. Some say it's status register, some say it's flag register. So it depends that which microcontroller or which company microcontroller are you using. For example, you people have to find that what are the other registers of this status register and what is their bit location. For example, there is a carry register, carry flag, there is a zero flag, there is a negative flag. You people, these flags are exist in these status register. Similarly, there is a interrupt flag. Find this status register and try to locate that where your flags exist in this status register. Okay, for the moment we just want to discuss about, let's say, carry and zero flag. What is carry flag? Carry flag is if your result of ALU in your processor, if result of ALU is greater than its limit. For example, what is the limit of your AVR registers? It's a 8-bit registers, 8-bit data bus. So if your value in your result of ALU increase from 255 value, because 2 raised to power 8 minus 1 is equal to 255. This is the maximum limit of unsigned numbers that your register or ALU can calculate properly. Now, if your value is greater than 255, what will happen? Carry flag will get high. You can use carry flag, or carry flag can be indication that your this result or your calculation is wrong. For example, you are adding 250 plus 7. What will happen? 257. The binary of 257 you can find it, but or if you are just adding 255 plus 1, it will be 256. Binary of that will be 10000000. Now your carry flag will become high. This high indicates that this result, if you are considering only this result, it is not correct. Either you should combine this result, or you may need to do some other processing to save your this whole result. Now at the same time, if you look at this result is 0. The result of ALU is 0, which means 0 flag will become high automatically. So carry flag is high, 0 flag is high. Similarly, negative flag. Negative flag is if your most significant bit is 1, your negative flag will be 1. So here negative flag will be 0. So one calculation done by ALU can affect multiple flags. So when are you memorizing instruction or understanding instruction, you should also understand that which flags will be affected by that instruction, because our branches are going to use these flags. Now let's see example. For example, we are using a instruction which use 0 flag to take a conditional jump. How to use? We have two instructions which are using 0 flag. Branch if equal, branch if not equal. What is equal? If result, what result? Result of ALU is equal to 0, then take jump. Where? Jump here label. Jump to, let's say, 6th position. Jump to, let's say, label 3000, whatever. If for this, if result is not equal to 0, then take jump. No, hope processor will do this thing or its architecture, how will perform this instruction? We have learned that when our result is 0, for example, if we are add R16, R17, it will add R16, R17 and store our result in R16. What will happen? For example, this have value 255 and this have value 1. So 255 in binary is 1111111, and this have 00000001. Now what is going to happen? When you will add these value, ALU will add these values and the result will become 0. Add this when our result is 0. So our R16 will contain this 0 value. At the same time, our carry flag and Z flag will become high. So when Z flag will become high, here this condition become true. When Z flag is 1, when Z flag is 1, when our result is 0. So on our result, when it is 0, our Z flag will be high, and this instruction actually checking the Z flag. So here result is 0, Z flag will become high. That instruction mean it becomes true and it will take jump. So it will be jump, and where we want to jump, let's say label 3000 or label 200, where you want to go. Okay. Similarly, if when we want to take jump, when result is not 0, here the Z flag is high, so branch not equal means result is not equal to 0, it will not take jump. If you are saying here branch not equal label, it will not take jump in this particular condition. Why? Because our result is not, it is equal to 0, it is not non-zero value, so branch equal not equal will check our Z flag, is it equal to 0? No, at this time it is not equal to 0 because our result is 0 and it is 1, so this instruction will not be executed. We will see how we can use this instruction over in programming, but first of all try to understand that which flag these instructions are using. Similarly, you can take jumps on carry flag, you can take jumps on negative flag. Now this is your task or a small assignment, that you look at your book and try to find that how to use other flags for taking jumps or taking conditional jumps. I have taught you 2 jumps instructions. I will also teach you assembly language programming, how to use these instructions, but you also look that how carry flag or negative flag or which flag actually we are using for taking jumps, and what are the instructions for those. Simply you can look at your chapter, in your book chapter you can find the table of all jumps. There are actually 8 conditional jump instruction in your books. 2 I have taught, 2 checks carry flag and 2 checks negative flag and 1 check V flag or sign flag. No, you people have to find that instructions. Now let's check that how this instruction use. First of all, this instruction takes 2 cycles or 1 cycle. This is also our duty to check it, and how big jump you can take, it is also our duty to check it. That for example, branch equal label, it will take branch when our result is 0 or our Z flag is 1, then it will take jump. But how long jump can be taken, this is not your task. When you will look at its instruction format, you can find these 2 things, that either it is taking 2 cycle or 1 cycle, and secondly it will how big jump it will take. Why I am leaving this to you? So you people should open your book and you must go through once from your book that what is the format of this instruction, and either it is taking 2 cycle or 1 cycle. The quickest way to look at this, just go at the end of your book and you will find the instruction summary. There you can find every instruction. It will tell you this is the format of this instruction, it is taking these cycles, 2 cycle, 1 cycle, or whatever, and then it will tell you that which flags will affect these instructions, and it will also give you 1 or 2 examples to use these instructions. Okay, so it is very easy. One, you can find in your book chapter of branches or jumps where you can find this. The other is, just go to end of your book chapter and find the instruction summary. You can easily find this. Okay, now how to use it? For example, if in C we say if our result A is equal to 5, then execute this code, else do this one. We want to implement this if and else structure in our assembly programming. How can we do? Let's say our value, if A is equal to 5, it will run this program, and if A is not equal to this, our program should be run these instructions. So how we can do in assembly? We have learned 2 instructions, branch equal, branch not equal. So how can we do this instruction? For example, and you know that our ALU actually do all the processing on our register. For example, in our register R15, R16, there was a value 3, and in R17 there was a value 1, and we perform this add R16 R17. What would be the result? The result would be 3 plus 1, 4. So result of ALU is 4. Is it equal to 0? No. So if you want to take jump at this position, what we can do? We can use branch. Result of ALU is not equal to 0, and we want to take jump. So what we can do? We can use not equal. Let's say here you have label code required. You want to run this code. So what you will do? Add R16 R17, branch not equal, code required. Your R16 R17 result is not equal to 0. Your this instruction will check your Z flag, because this is not equal to 0, your Z flag will be 0. So when Z flag is 0, this instruction become true, this condition become true, and it will take jump. Here your code will be run. Okay, no, you don't want to run actually this code. You wanted to run this code, these 2 instructions. You have checked here that your result is less than 5. You don't want to run this code. You came here, you ran this code. Now you want to go back or somewhere, maybe at this point or some other. What you can write? You can write R jump. Let's say you want to go here. Here let's say label if. You ran the code of else or code else. I can write here. It was less than 5. You you ran this code, and after that, for example, you want to go down here, out label. So here you will write r jump out label. So what happened? First you executed an instruction, so our flags get affected, because our flags, how can our flags get affected? Only by doing some process through ALU. Okay, accept interrupt flag. Here your this instruction will affect your flags or your status register. Here we check the zero flag was not high because it was not equal to 5. Sorry, it was not 0. When it is not 0, it came to this position. We ran this code. After that, if we just want to go through this, it's okay. Otherwise, if we want to take jump, we can take jump or jump out label, and you can go somewhere. But if we want to go back again here, let's say label condition, this was our condition, and before coming out, what you are doing here, you add R16 plus 1, and now again you want to check that your R16 is equal to 5 or not. How can we check? Simply, instead of this, for example, our instruction was like this: subtract R16. I am taking a new example. R16 was, let's say, 6, 7. Now what is we are happening here? Subtract R16, R17, 7 minus 1, 1. This result is not equal to 0. This code will be run. No R16 or R16 here, except add. We can do subtraction. R16 1. No R16 value will be 6. Here, instead of this, I am coming back to our label condition. Label condition. So from here, we will come back here. So what will happen? It will again, here we have removed 1. Now it will subtract 6 minus 1. What would be the result? 5. If I move here actually 5, because I want to check that it is equal to 5 or it is not equal to 5. If here I have 5, now what will happen? 5 minus 5 will be 0. When it is 0, then now what will happen? This instruction will not execute. This instruction will not get executed. But here we want to take jump. So what we can do, that we don't want to reach up to this instruction. So or we want to take some decision when it is 5. So if you want to take decision at that time when it is equal to 5, 5 minus 5, 0. So we can